Example 2 in section 2.3 returns to the concepts of revenue and profit. This problem states that Widgeco is a company that produces and sells widgets. Their marketing department has determined that the price per widget, which is indicated by the variable P, and the monthly demand for widgets, indicated by X, are related by the following price-demand function. So this P of X function here. This explains the relationship between the price per widget and the overall monthly demand for widgets. The problem also gives us a cost function, which tells us how much Widgeco would have to pay to produce X widgets. And now we're going to construct and study the revenue and profit functions. We actually did that once before for this exact same problem. If you go to section 2.1, example 4, we have the same information, and from that we constructed the revenue and profit functions and then just saw how to work with them. We plugged specific numbers into them and found out the profit and or the revenue at certain production levels. Okay, well now we're going to push that just a little bit further and start looking at trying to figure out how we can see where the maximum revenue and the maximum profit occur, where those occur at. So starting with part A, we're asked to find the revenue function. Again, we've done this once before, so you can refer back to example 2.1, section 2.1, example 4, for help on this, but I'll do it again here, but much quicker. So revenue is equal to demand times price, or in other words, X times P of X, and P of X is 300 minus 2X. So my revenue function, R of X, is going to be 300X minus 2X squared. This tells me the amount of revenue associated with a certain level of demand, or in other words, a certain production level. Okay, now before I go further, one thing we can notice about this revenue function is it's actually a quadratic function. Now, I'm not going to bother going through the steps to find get a complete sketch of this graph, but you can see right away that it is a quadratic function. Also, because of this minus 2 coefficient on x squared, you can see that the parabola representing this function is going to open downward. If we did get a sketch of this, we would find out that there was an x-intercept at 0 and an x-intercept at like 150, I think. And then a vertex up here somewhere. So our revenue function, if we sketched it, would look something like this, where the x-axis indicates demand and the y-axis, the height here of these points, represents revenue. Okay, that's important because in the very next question, we're going to ask to find the production level that results in the maximum revenue. So the maximum revenue is going to be the highest point on this revenue curve, and so the production level that gets us there is going to be the x-coordinate of that point. In other words, the x-coordinate of the vertex. So we already know how to find the vertex of a parabola. We use the formula x equals minus b over 2a. So my b in this case is 300. So I have minus 300. A is minus 2. So I have negative 4 down here. The negatives cancel. 300 over 4 is 75. So 75 widgets is the production level at which we see a maximum profit, the largest possible profit. Now, that's only the x-coordinate for the vertex. Like I mentioned before, the x-coordinate of this vertex gives us the production level that maximizes profit, but the y-coordinate is going to give us the actual maximum profit. So in part C, we're asked to calculate that, to find the maximum profit. So to do that, I know the production level which produces the maximum profit. I'm sorry, the maximum revenue. I've been saying profit for the last couple minutes. I mean revenue. So to calculate the actual maximum revenue, I plug 75 into the revenue function. So I get 300 times 75 minus 2 times 75 squared. I plug all that into the calculator, do some calculations, and I get that the maximum monthly revenue is $11,000 250. Okay. So make sure you understand that before going on. In the next few parts, D through G, we're going to be doing something very similar, but this time with the profit function instead of the revenue function. Okay, so now in part D, we're asked to find the profit function P of x. Again, we did this once before. The function P of x is revenue minus cost, or revenue is 300x minus 2x squared minus our cost is 1200 plus 40x. I can distribute the negative through on that to the bit on the right, and combine like terms, do some simplification and that sort of thing. And we're going to get the profit function minus 2x squared plus 260x minus 120. Now again, if I wanted to know the amount of profit associated with a specific production level, I would just plug that into this profit function. We did that before in section 2.1. But what I really want to do in this problem is find the production level that gives us the maximum profit, the largest possible profit. So, again, if you look at the profit function here, you can see pretty clearly that it's a quadratic function. So its graph is a parabola. Because of this minus 2, we know the parabola opens down. Don't worry about getting a sketch just yet. I'm going to get a rough sketch of it here, and then you can just take my word that this is what it looks like, and then you'll start to see, get a better idea of what it looks like as we go through the problem. But we have a parabola, something like this. If you graph this parabola, y equals p of x, you're going to see that the graph is a little bit different than the revenue function. There are a few differences. For one thing, the profit is always less than the revenue because you're subtracting off costs. So that's one big difference. But just like before, the x-coordinate represents demand, and then now our y-coordinate is going to represent profit. Okay, so I want to find the production level that gives the maximum profit. So just like before with revenue, that's going to occur at the vertex. So I want to find the x-coordinate of this vertex. I do that using the vertex formula. X equals minus b over 2a. B, in this case, is 260. A is still minus 2, so I have minus 260 divided by minus 4. That turns out to be 65 widgets. So that is the level of production, the production level that generates the largest profit. It's worth noting that that is different than what we saw for largest revenue, which is kind of a strange phenomenon, that the production level which gives you the maximum revenue would not also give you the maximum profit, but it turns out to be true. Basically, the idea is if we go from producing 65 widgets to producing 75 widgets, our revenues are actually going to increase because our maximum revenue is actually at 75. But not only are our revenues increasing, our costs are going to increase. And within that range, from 65 to 75, basically what happens is the costs sort of outpace the revenue. And so you end up losing profit by producing those additional 10 widgets, even though your revenue is actually higher. Okay, so in part F, we're asked to calculate the actual maximum monthly profit. So since we have a profit function, P, and we know that the maximum profit occurs at 65, we just plug 65 into P, and that's going to give me minus 2 times 65 squared plus 260 times 65 minus 120. I plug that into the calculator, turn all the cranks, and I get 7,250. Okay. And again, what we just did is basically find the y-coordinate for this vertex. the y-coordinate is going to give us the actual profit associated with this. Hence, it gives us the maximum profit. Okay, the last part of this problem, we're asked to calculate the break-even points. In other words, find the production levels at which WIDGCO breaks even. So break-even, as you've hopefully read in the notes, break-even occurs when revenue is equal to cost. You have exactly as much money coming in as you have going out. That's equivalent to saying that your profit is equal to zero. If your revenue is equal to your cost, then you are making no profit. You're not losing money, but you're also not making any money. So I want to calculate the points where WIDGCO breaks even. Well, if you look at the picture here, you can see that if you look at this graph, you can see that the profit is zero right at these x-intercepts. So I'm going to have 2 points where we break even, and I want to find both of those. So since I'm finding the x-intercepts of a parabola, I'm going to have to use the quadratic formula. In essence, what I'm doing is I'm solving the following equation. Minus 2x squared plus 260x minus 120, so that's the profit, and I want to set that equal to 0. Okay, so I do that using the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Okay. So I'll leave it to you to actually calculate that. It's basically just a lot of calculator work. What I would suggest is step 1, make sure you calculate everything under the square root. Step 2, actually process the square root. And then, step 3, do the minus 260 plus or minus all the square root stuff. And then finally divide by minus 4. But anyway, if you go through and do all of that, you're going to get, and the problem asks us around to 3 decimal places, so we're going to get 2 solutions, 4.792, and the other one is 125.208. So these are the production levels where WIDGCO breaks even and doesn't make any profit, but they're also not, losing money.